Welcome to the practice set for the distributive property. Please like and subscribe if you find this video helpful, or leave a comment and let me know what you'd like to see more of. Pause the video to work these problems and then come back to check your work. Right, first off, we've got some pretty straightforward distribution problems here, and there is flexibility here in how much work you show. So we have first 4 times y plus 6. So at the bare minimum, you do need to show that you have done 4 times y to get 4y and 4 times 6 to get 24. I would give that 100% credit in my classroom. Now, when you're first studying the distributive property, there is a chance that you might need to, or someone might require you to show 4 times y plus 4 times 6. And that would just be a little bit more evidence that you know what processes are happening here. And then some students do opt to show little lines indicating that they are distributing the 4 through the parentheses. I wouldn't require that, but again, as I always say in my videos, you listen to your teacher and what your teacher wants to see in terms of work. For number 2, we have 5 times x minus 3. And the minimum amount of work that you would show here is 5 times x gives you 5x, minus 5 times 3 is 15. And so you would have 5x minus 15. Other pieces of work that you might show is you might show that subtraction as adding a negative. And what that does is it emphasizes that you are multiplying by a negative 3 there, not by a positive 3, and just bringing the subtraction along. You might also want to show that 5 times x plus 5 times negative 3. And then if you do that, you might end up leaving your answer in that form, 5x plus negative 15, and that is 100% fine, at least for me. Now, again, your teacher might want you to show the subtraction. My Algebra 1 teacher required that I showed the plus negative. You know, just do whatever you need to do for your teacher. Last one there, we have negative 7 times 2x plus 4. So this one introduces the idea of maybe having a coefficient in front of the variable there. And so minimum amount of work, you do negative 7 times 2 to get negative 14, and then you'd have negative 14x, and then you would have negative 7 times 28, which you might go ahead and write as minus 28. You might also say negative 14x plus negative 14x plus negative 28, because you've got that plus sign in the parentheses there that you might retain. And again, you might see this negative 7 times 2x plus negative 7 times 4. Ultimately, one of these two should be your final answer. You should not leave it in that intermediary step. Okay, just a couple more. So this one introduces the idea of multiplying by a negative, but then you have a subtraction on the inside. And this is where it might help to picture that as plus a negative, because what you're doing there is you are actually doing negative 7 times x plus negative 7 times negative 6. Negative 7x, and then a negative times a negative would give you a positive 42. A lot of times with my students, that is something they miss because they're not quite sure about the minus sign versus the negative out front. So by changing everything to that plus negative, you see a little bit more clearly why it's the 42 is positive, and then the plus sign is already there, so it's not like you're making a plus sign appear. I wish I had a nickel for every time a student asked me where did the minus sign go, or why did the minus change to a plus sign. So I think by doing the plus negative there, it's a little bit clearer what's happening. Number 5, we have 4x times x plus 1. So this one introduces the idea of a variable like inside the parentheses and also a variable outside. So this would be 4x times x plus 4x times 1. And of course, 4x times x, if you have x times x, that would be x squared. And 4x times 1 is 4x. And last one, this one has the distribution coming in from the other side, which is uncomfortable. I can't type really easily to get that little dot. So, and I don't want to use an X since we already have an X in there, but typically you probably would see a little dot there, but you don't have to. It's the same principle. And so you can distribute in from the other direction. So you do the same, or you can rewrite it if you would prefer. You can rewrite it in the other order so that your distribution is going from left to right. But we would have 3 times x squared, which is 3x squared, 3 times x, which is 3x, and then this would be 3 times -3 if I do that little notation change. So plus -3, 3 times -3 is -9, or you can write it as -9. Either one of those is algebraically correct. All right, these ones are some simplify problems. And so in this first one, you've got a couple of x squareds and you have a 2x and you have a 4 here. And so when we combine like terms, we're always looking for the same variable. And what we're doing usually in our heads is we're saying, okay, the height of that rectangle was x squared and the width was divided into a 6 and a 4, or 6 and a -4. And then these other ones don't have anything that match. So you got an x and a 4. 6 minus 4 is 2. And you do not have to show this step, okay? This is optional if it helps you to picture it. But usually once we spot the like terms, we say 6x squareds minus 4x squareds, or 6 of them, take away 4 of them, and we're left with 2 of them. Next one just looks like a soup of stuff. So this is awesome. 3x squared plus 2x squared plus 3x minus 4x plus 5 plus 6. And I did put all of the like terms next to each other, but they don't have to be next to each other. I think I changed up the last one from what I had written earlier. So we have 3x squared plus 2x squared. Sorry, that's -3x squared. So that's -3 plus 2. Going with the x squareds. Here we have, find a different color, we'll do a light blue. We have the x's, and so we'd have 3 minus 4, and that'll be an x, and then these two are the same, and so those just add to 11. You can go ahead and do that adding there. In the purple down at the end, -3 plus 2 is -1, so we have -1x squared. Then we have another -1, so that's awesome. 3 minus 4 is -1x plus 11. That should be correct, but other things you might see are -1x squared, with this being a -1x, and then the 1 does not necessarily need to be written, because 1x squared is just x squared, and so you might just see x squared minus x without that coefficient of 1, and that would also mean the same thing, because 1x, 1 times anything, is the anything. And so if you have the negative out in front, that actually doesn't change anything about that. It's just a -x. So all of those should be okay. But again, always listen to your teacher, and what your teacher says is the form of the answer that they want to see. And last but not least, we have a lovely geometry problem here. This one is find an expression for the perimeter. So that does require that you know what the word perimeter means. And if you're online watching this video and you don't know what it is, you can always do a search for it to say, what is perimeter? Perimeter is the distance around the outside of an object. Okay, so if this were an art gallery and you're the security guard and you're going to walk the perimeter of the art gallery, okay, you'd walk here and then you'd walk here, you're walking the perimeter. And the distance that you walk is the number for the perimeter. It's how far did you end up walking? So what's the tally on your Apple Watch for your steps for the day? So for the perimeter, we would take one of them. So we'd have x plus 4 plus 2x plus 3 plus x. So we would add them together. And those parentheses there, I don't want them to throw you for a loop. They are what I would call cosmetic or decorative parentheses. They don't serve an algebraic function because there's no distribution happening in this particular problem, at least not the way that it's written. They're just meant to set off the different sides from each other. So you're kind of grouping one side together and another side together, but it would be equally correct to just say, I'm going to add all that stuff together, like so. Okay, now we'd look for those like terms. So that's where the distribution comes into play. So I have an x, and I have another x, and then I have another x over here. So I have x plus 2x plus x. So I'd say to myself, how many x's do I have? X plus 2x plus x. That's 4 x's all together. And then right in here, we have 4 plus 3. And so 4 plus 3 is 7. So regardless of how you set that up, your final answer should be 4x plus 7. And remember, your like terms don't necessarily have to be next to each other. Okay. And what you do to set this up, I would say you need to show at least one of these. Okay, in order to demonstrate that you did not copy it from a neighbor or get it from the interwebs somewhere, that like you actually have the work there. All right, so as always, if you've thought this video was helpful for solidifying your knowledge and skills in the distributive property, please give it a like, subscribe, ask me a question, interact with the video. I'd appreciate that very much so that I can know what people need to see. Thank you, and I'll see you in the next one.